Welcome once again. I'm Liam Kennedy, your host for tonight's episode of Look Up Tonight. This is the cable show of the Orange County Astronomers, and we're one of the largest amateur astronomy clubs in the country and invite everyone to watch our show and to learn what our club is all about and how you can learn about this wonderful hobby.
First of all, for all the astronomers here who have been frantically looking to try to figure out Ultima Thule there, what star exactly is that? I've had a little fun with you. That is, in fact, no star whatsoever. That is instead the ancient land from the classical world, the mythical land of the extreme far north. And that is where we are heading tonight in celestial terms. I've done 2 of these other tours before. However, tonight you're going to be getting a lot more miles on your frequent flyer cards because we're going more than twice as far as we went in the last 2 tours combined. There's a reason for it. There's something a little farther out that really requires some looking at. And it is the thing just about in the center underneath the title, the rather familiar group of stars there, which is to say the only stars most people in a bar have ever heard of, right? Now, it is not the brightest group of stars in the sky. It is not the biggest group of stars in the sky. Heck, it isn't even a constellation. But the Big Dipper is without a doubt one of the most famous things in the sky, the most famous really, and I have had a lot of requests to do something about this and take a tour out there. That's what we're doing tonight. Now, why in the world would those be so famous? Well, of course, now most of us, we know these stars because they are close to the North Celestial Pole, at least right now. The Big Dipper pattern, we know the last 2 stars in the bowl. Every Boy Scout knows you take that out to find the North Star Polaris. Being close to the North Celestial Pole actually is a big deal. For us, it's curiosity, but in ancient times, it was tremendously important. This is the point at which the entire sky seems to rotate at night, the most fundamental system of organization ancient people knew about. They were really impressed with the place the sky seemed to rotate around. Now, that doesn't mean that this point here that we know today has always been where it is. In fact, it hasn't been. It's wandered. You would think this would be the big deal constellation. It isn't for 2 reasons. Number one, the North Celestial Pole didn't used to be there the whole time, so ancient people didn't worship it. And quite frankly, it's a pretty boring little group of stars, just barely a constellation at all. No wonder then that the bigger neighbor got the nod in ancient times. Now, the Big Dipper was in fact closer to the pole in ancient times. Excuse me, I'm learning to squeeze my mouth, excuse me. The suit doesn't necessarily clean up the act, does it? I was better behaved on the ship, really. This shows where the sky seemed to rotate around in ancient times. And actually, as you can see up in through here, the periods, for example, when the pyramids were built, it was out here, very much closer over to these stars. And the ancient people certainly knew that. Ursa Major, the big group of stars, was really the way to find the North Celestial Pole, this point where everything seemed to rotate around. Now, in Greek times, as a matter of fact, they mention specifically that of all the constellations, only one of them never took a bath. Seriously, they thought the whole edge of the world was an infinite ocean, Oceanus, and the constellations, as they went around and around the pole, which was right here back then, these constellations never actually got far enough down to dip into the water. So now you may just think this is a hygiene problem for the bear. And they did see it as a bear. The Greeks saw it as a bear in ancient times. It's kind of hard to make a bear out of it in some ways, not the least of which being bears don't have long tails. The Greeks explained that by saying when they got thrown up there by Zeus, he stretched the tail. I'm not kidding, that's the story. This is what people did before TV. We use our telescopes to look at these stars. Actually, we don't. I know you guys out there with the big artillery here, I mean telescopes. You folks probably spend lots of time looking right through these stars, but almost never at them. You look at the galaxies that are out there in the background, but almost never the Big Dipper itself. There's a reason for that, because they are really just little points of light. Sometimes we can't imagine there's anything that exciting about them, so we look at the background. As famous as this constellation is, most astronomers here pay very little attention to the Big Dipper itself. Now, should they? Is it a big deal? Well, hold on. Let's take a modern look at the Big Dipper. First of all, page 1 of the Thomas Guide, as I've often said, our galaxy viewed from above, the way you'd see a map of a city, looking down on it with all the streets laid out. Fair enough. However, I've noticed something in science fiction. You notice there's never any up and down in sci-fi? You probably remember, what was it, the second Star Trek movie where Captain Kirk gets the idea to go down. And that fools them, right? It's like, I never thought you'd do that. Well, the problem with tonight's tour is the last tour, or the first tour we took, was a short hop from our sun's position, a very short hop, towards the center of the galaxy and back. The next one we took was toward the outside of our galaxy and back, but tonight we're doing one of the other obvious directions. The Dipper is up. So to really get a sense of that trip, this map wouldn't do it all. You'd have to look at the galaxy sideways. So the Great Flying Hamburger would see edge on. The trip that we would be taking is out here from the burbs, looping up and then back down. Not that much. We're still staying in our local area. It's important to notice the different components of the galaxy here. You all know those beautiful blue spiral arms. There are other colors of stars there too. It's the bright blue ones, the young stars being born in the gas and dust that's confined to the plane of our galaxy. So they occupy a very narrow flat zone in here. You probably know our sun is also in the disk, the flat disk of our galaxy. Some of you, however, may be a little surprised at the Dipper stars, where they are in our sky, because they're in the disk with us, but you probably know that the Dipper stars are almost straight up, as I've mentioned. This is the actual straight up from us in the galaxy, the galactic North Pole. Ursa Major is just about as north as a constellation can get, because Earth's North Pole is over here, the galaxy's North Pole is over here, and it's the one in between them. So it wins on all the counts you can get. It's almost straight over us, and these stars, almost all of them, you probably already know, are blue stars. But they're supposed to be in the flat disk. What are they doing over our heads? Did somebody throw them up out of the galaxy? Why are they hovering up there? And there are other blue stars in this direction. Up above us, Regulus is up there, and even farther away, Spica. Now, this doesn't mean these stars are not in the plane of the galaxy. There are two different explanations for why our destination tonight is up, even though these are Milky Way sorts of stars. One of them relates to photographs like the one you saw earlier in the What's Up. If you look at this very closely, this is the Milky Way towards the center of the galaxy, as obviously seen from the sun, and you'll notice that up in this direction, south and down in this direction, you notice we only see the bright glow of the Milky Way, the brightest part, on the south side of the center of the galaxy. As a matter of fact, if you do a statistical analysis of the Milky Way all the way around you, you'll find it isn't exactly on the waist of the sky, but the Milky Way is deflected about 1 degree upwards in every direction. What this means is that the sun is the problem. It isn't the Dipper is up. We are probably slightly down. We are peeking under the galaxy's skirt here to see the bright glow, the beginnings of the bright glow of the center. The actual center is located right about here. So even though it's a little bit fuzzy and hard to determine, we are probably a little bit underneath. Now, underneath is a relative term. The galaxy's disk, seen close up in edge on, is probably, 3,000 light years thick. Now, so we could be here, and the Dipper could be here, okay? There's plenty of room for up and down. Don't expect to go flying out of the galaxy on a trip as short as the one we're going to be taking. We don't have time for that. Are these stars really unique and important? Yes, they're close to the Earth's north celestial pole. Yes, they're blue stars, a famous constellation, easy to recognize. It turns out that most constellations are accidents. They're just groupings of stars, some close, some far away. They happen to look like a bear, a dragon, a lady's wig, whatever it is. Coma Berenices, I'm not kidding, it's a real constellation. Why would we care so much about these? Well, it turns out they have another secret. All the stars out there are moving as they all go around the galaxy. If you plot their motions, you'll find out that some move together. The entire center part of the Big Dipper is moving together. They are not just random stars. The ones at the end are headed the wrong way. They are clearly not involved. But this one, and a variety of other, actually I didn't even mark them all, hundreds of stars all over the sky are moving with these guys. What that means is that this isn't a constellation so much as a star cluster. It is, in fact, the closest of all of the star clusters. It's just 80 light years over our heads. It's so close that it looks like a constellation. Now, I love star clusters. I love looking at these things with my telescope. Some of these things seem like impossibly crowded and dense gems off there. And if you got in the middle of that thing, you'd have stars burning holes in your hair and in your pockets. There'd be stars everywhere, right? Well, hold on. The images can be a little deceiving. Those stars are really small, and they're actually pretty far apart. If you got in the center of one of these things, what would happen is these would be bright stars all over your sky. As a matter of fact, the Big Dipper cluster, although a fairly sparse and small group, would look pretty good. It'd look about like, say, this part of this star cluster in a telescope from a long way off. But if you're right next to it, it looks like a constellation. In fact, we're so close to this scattered group that some of the stars in the Dipper group are on the other side of the sky, which means, put the other way, we're in a star cluster. We're passing through one right now. The surest possible way to not notice something in astronomy is to live inside it, right? How long did it take us to learn we were on a planet, okay? We're right next to one of these star clusters. So since we've got one close, it makes sense to have a look at one of these families of young stars. Our trip, as I mentioned, is up. This is the only time I will show this horribly confusing graphic. However, for college students, if you reference this or get an image of it off our website, you will pass the class. It looks very sophisticated. The truth of the matter is, all we're really doing here, this purple grid shows you flat in our galaxy. Our sun is right here, and we just lift off in the green arrow and head up here. Here's where the cluster is, 80 light years away. Naturally enough, I'll knock off a stop or two of them specifically on the way up, and then once we drive back down through the star cluster, we do stop one more time for last-minute shopping opportunities. We race on through and visit 2 more spots before coming on home. Total travel distance will be approximately 350 light years for this trip. Seen in the sky, a little more familiar perspective, this is what the trip looks like. I chose this topic for the spring and summer months because the stupid stuff is hanging over the parking lot when you leave, right? It's one thing to have somebody tell you about this stuff. I have to, as an artist, imagine a lot, and I'll tell you what I'm imagining that we might find when we're out there. The point is that things really are there. Please take advantage of the fact these stars are there tonight and have a look for yourselves. Starting out here, leaving home. Okay, we kick in the hyperdrive, start pulling away. First things first, we see a view of the Earth as we're leaving that is completely unlike anything the Apollo astronauts ever saw on their way to the moon. Why? We're headed north. We're headed over the crown of the Earth. The moon is never this far north, so the astronauts didn't head this way. In fact, no astronaut has ever seen the Earth as a little ball at this angle. You can certainly see the city lights of Los Angeles out in there. You're kidding me? Look, there's Florida, and there's the Baton Rouge and Louisiana, there's New York City, and while you're at it, you can tell that the summer's gotten started because the North Pole is now in sunlight. So you can definitely get a look at the stars. You may also be able to look in the background here. You see Orion in the background. These are the deep southern stars. That's Arcadar down in there. The reason the southern stars are important, when we go up, the Earth goes down. That's why you'll see the Earth and the sun and all that down in the southern stars, because we're riding the express elevator up. Now, we're not going to go very far on the first flight. I'll give you a little in-flight movie while we're waiting. Stars do not always have romantic names. Lalande 21185 happens to be one of the very closest stars to us. It's in the constellation of Ursa Major, and it is far too faint to see with your eyes, which may surprise you for the close stars. Most stars are very faint, and even the close ones you can't really see very obviously. The interesting thing about Lalande 21185 is that in 1996, astronomers found 2 Jupiter-class planets orbiting this star. This was one of the stars that had always been reported as having planets even as early as the 1940s. Those were mistakes. It turned out that it really did have planets after all. It's a solitary star like our sun, but it's a lot fainter. So these planets must be incredibly cold places. For example, in here, you see the inner planet there. There's the habitable zone in green where you could have an Earth. This planet right here, even though it's only 2 astronomical units away from the star, that's just a little bit farther out than Mars, it is about as cold as Saturn in this solar system. This is trying to keep warm with the cigarette lighter in Antarctica, folks. As we drop into the system for a quick look, you can see what I'm talking about. There just ain't much sunshine. You lay out 5 weeks to get the beginnings of a tan, okay? That star is really trying, but it is, I believe, 6/1000ths as bright as our sun. And very orange. That's because the star is burning at low temperature. This is a typical spot in our galaxy. Most suns are like this. Our sun is brighter than 90% of the other stars. Doesn't hold a candle to the Big Dipper stars. So it's kind of interesting to see a star out there that is so incredibly faint. Now, one interesting thing about this, the constellations actually haven't changed too much yet. This, for example, is Perseus from out here. We've only moved 8.3 light years. So most of the constellations look pretty familiar, but that's going to change as we move farther. Now, one analogy I'll use later in the program is floors in a building. Since we're going up, if 1 light year equals 1 floor in a skyscraper, we're on the 8th floor here, okay? When we get up to the top level, we're going to be at the 121st floor. By that time, the stars will look pretty weird. Now, our next spot, Lalande 21185 is right here, is right next to it here, star called 47 Ursa Majoris. You may have heard of this one. It's a must stop. It is not a dipper star any more than Lalande 21185 is, or a 47 Ursa Major, fairly faint, naked eye star in there. Most of you guys never pay any attention to it, but this is one of the places we have found planets, and it's a lot more exciting because the star involved is one like our sun, a lot like our sun, almost a copy of our sun. So we've got these 2 planets here, but you know it's kind of heartbreaking? We found these planets, but look where they are. Big Jupiter-type planets, and one of them is really close to where an Earth would have to be around that star, almost on top of it. If theoretically, in fact, you probably couldn't have an Earth there. The orbit would be shaky. So astronomers were debating back and forth in their minds if life was possible here. The 2 gas giant planets, we're assuming they're gas giants, are probably in conditions, even this one, where water would be a rock, but a slushy rock, that kind of conditions, about equivalent to the outer asteroid belt in our solar system. We do not know about moons. We do not know about smaller planets yet. We can't detect them. As an artist, I'll show you what I think are reasonable scenarios for what we might find at this very important star system. Dropping out of hyperspace here into 47 Ursa Majoris, dropping by the outer gas giant planet here. First of all, nice sunshine. Familiar lemonade-colored sunshine. This star really would look like home, no doubt about that. It is about 1.8 times as bright as our sun. It's an old star, about 6 to 7 billion years old, and it may be just starting to enter the last phase of its life. So there may be kind of a danger that way to the planets. One of the great questions astronomers have is, did these gas giant planets form in a little bit close, in snug like this? Or did they wander in? Were they originally like Jupiter and Saturn, farther out in our solar system? And it turns out that theoretically, gas giant planets may scoot in closer over the lifetime of a solar system. If so, maybe this was a system with an Earth in it. The planets moved in and caused chaos. So as galactic sailors here, one of the first things we're going to do is look for evidence of what happened here. to see what the deal is. Now, the gas giant planets themselves wouldn't tell you much, just swirling clouds of gas and so on. It'd be the surfaces of the moons that would really be especially revealing to show cratering counts and violence that happened there and so on. And for example, this imaginary moon we're passing here, you'll notice the surface has been fractured. There aren't that many impact craters. Water ice has probably flowed across its surface, a lot like Enceladus in our solar system around Saturn. So that's a choice. That means maybe something could happen there. Notice also the planet has two ring systems, not dynamically stable. Looks like two moons hit each other, especially since the outer ring is made of coarser material and is probably a young ring. Those are some of the kinds of clues we might get if we could really fly here. One other thing to note do we have any committed drunks who like Fosters? I'm very fond of Fosters, and you know the flag, the Southern Cross flag. This is, in fact, the Southern Cross, for those of you who love it, right here. Now, what's happened is we're 45 light years from home. We're up on the 45th floor, and that star on top of the Southern Cross is closer to Earth than the other ones. So you know what happened? We rode the elevator up. That star dropped right down. So the star moved off the top of the Southern Cross, one of your first clues. One of the other things you might look for if you know the stars, this is Beta Centauri, and this is where Alpha Centauri is supposed to be from home. We're 45 light years away. Alpha Centauri's 4 light years. It went voop and is now a 4th magnitude star. So you have definitely moved into a different scenario here. Now, the inner planet is a little bit bigger. It is, in fact, heavier than Jupiter. It could have some pretty exciting things going on with it. Imagine that we find a large moon, for example. I mean a big, nasty moon. We think of Titan and Ganymede and Callisto as being big moons. Okay, they're the biggest we got, ballpark of 3,300 miles. What if you found an 8,000 mile across moon? Well, as sailors, that would probably perk our interest, because what it would look like is that it might have been a planet that was captured by this gas giant planet. One of the distinct possibilities in this system. Now, we're going to inspect this imaginary moon closer to have a look at it, but first I wanted to point out, for you guys who know the sky, you recognize Orion? Yeah, look at that lovely belt. There's the shoulder star, Bellatrix. It's squished down like this because it's closer. We went up and it went down. One of the other things that you notice on Earth a lot is the V-shaped star cluster, the Hyades, which is located right here, but they're missing the star Aldebaran, the orange star Aldebaran, which has also dropped completely out of position. Now, getting in close to this moon, this is a class of world we do not have in our solar system. It is a world as large as the Earth, but dominated by ice while still being active. The Earth looks the way it does to us, the blue marble business, because liquid water exists on its surface, but there's no rule that it has to be like this. In fact, you can see going on down on this moon just about everything that makes the Earth go on, except it's all in solid form. For example, you can see down here volcanic plumes. You can see the remains of a few impact craters, but not too many. There's obvious faulting that's gone on and cracks and so forth. This is a place that actually has a lot in common. It's just that the oceans are frozen. Now, I know you all want to drop down on the surface and have a look. By all means, have a look. This is basically Antarctica minus another 50 or 60 degrees Fahrenheit. So really cold, probably too cold for life. The big difference in the sky, of course, is that you have a gas giant planet looming up there in the sky. Giant moons are a distinct possibility here. You should remember, by the way, that the 2 planets we know of in this system already have twice the mass of Earth's entire solar system that we know about. If that means this star is twice as good at forming planets, there's no reason you couldn't have moons that are twice as large as any we have. Now, you can see the volcanoes going on out there in the distance. A world like this would be a lot of fun. You'd have to sneak up to the big volcanoes to get samples of rock where the ice had melted around them. Sorry about getting my shadow in the shot. I'm always doing that. So a lot like a place like Greenland or whatever else, definitely alien and not really home to life, but at least it's got a blue sky. Now, before we split, I know the Boy Scout rule, you never leave a planet except the way you found it, right? And that's fine with one small exception that I felt the need to make. You'll forgive me if I am an optimist. I do think that particular piece of cloth will end up flying in places like that. And no, I didn't get the number of stars wrong. I think 56 is a reasonable optimistic estimate for the near future. Canadian people, please don't get mad. You'll make great Americans. Teasing. So you could have a world like this, a moon or whatever else, that we find out there. It's what I call a Trojan horse planet. It looks like one thing, but really it's another. So basically, this is an Earth, but an Earth a few degrees cooler. So it looks different. Now, we have situations like that at home. One of them is called Mercury. It looks like the moon. It's rocky, it's covered with craters. We think it's the moon. But the studies of its composition and its magnetic field have suggested that it's identical to the core of the Earth. And it may be that Mercury started out like an Earth and lost its outer layers, either from heating or giant impacts, so that you are just fooled by the exterior appearance. So sometimes you have to go under a book's cover to get a good sense of what would really be there. Now, at the one loom position where the sun would be the right brightness, probably only asteroids. There's probably no room for a planet to be here. We're not sure, and this is one place astronomers will be looking very, very closely. Now, a sky mark is available ahead of you for the next stage of the trip, up about another 40 floors. This is the Big Dipper from here. This is the yellow star in the end, Dubby, which belongs here. It has dropped, or actually what's happened is all the stars in the Dipper have scooted up in the middle, the moving group that's really together. Mizar and Alcor are right here for you folks who know this stuff. Now we're actually going to be leaping into the Dipper itself, the proper Dipper. We start by hitting the bottom of the bowl. The reason we go for the bottom of the bowl is it's the closest. Star named Merak. Now, Merak may just seem like another blue star in there. Yes, it's about, 50 to 60 times as bright as our sun. Impressive, sure, by our standards. Nothing like a Rigel at 60,000, but bright and hot, sure. But the most interesting thing about Merak is something it looks like the other Dipper stars don't have. There's a unique quality to this star about 83 light years away. We have some experienced people who were out with me when we went to Vega. You remember that trip? You may recognize something. It's got one of these. It has a giant dust ring around it, big one. And what that means is a solar system forming right now. Don't drag your telescope out and try to see it. Number one, it's face on to us the same way Vega's dust ring is, so the light's spread out and we can't see it, especially with the glare of the star. This star is probably a little brighter than Vega really is. So you can't see this. We've only spotted it from the infrared excess radiated back from the dust. The dust is warmed by the star. We basically see the warmth from it. Now, if you get into a cloud of dust and gas like this, it looks pretty from the outside, but you get in the middle of the Merak party, folks, and things get a little exciting, especially near some of the planets that are forming as it condenses meteoric material into real swarms. They probably do happen, and only around forming stars you get the kind of thing you saw in The Empire Strikes Back, okay? But not in our solar system today. This process is over, and frankly, I'm rather glad it is. This is the kind of excitement we don't need. But it's not surprising that it's happening here. These stars do not live very long. We know they're young. In fact, the Dipper group is about 60 million years old, which means they were born just about the time that T-Rex kicked off, okay? So these stars are babies. They're just in the process of getting themselves sorted out. I know some teenagers like that. Now, with the star next door, we cut over to the other side of the bowl. Why? Well, it's close, and besides, when I looked out the window last time when I scouted this, I noticed something just funny I wanted to show you. First of all, I should make the point, this is the star Thecta, the gamma star in Ursa Major, another star very similar, but without the dust ring. There's no infrared excess. We don't think it has one. You know what else it doesn't seem to have? Planets. Where the reason we think maybe it doesn't is it spins really fast. It spins in a couple hours, and this thing's about 2 times as heavy as our sun. That suggests that there's no cloud of gas that ever formed around it. It all rushed in and just made a star. Now, the analogy that's always used is the ice skater. They think that angular momentum means, like an ice skater with their arms out, they spin slowly. So a planet that basically formed a system of stars transferred a lot of the spin out to the planets. A star that just took all the gas into itself spins up really fast. That's a clue that this star may have no worlds, which is really weird when you think about it. We're land critters. We need a place to stand, don't we? A space painting like this you can't sell because there's no landscape. And that's not surprising. I'm even freaked out by fish that swim around in the deep ocean, out in the middle. How do they handle that? There's no place to stop and rest. This would be a place like that where there's no up, no down, no destinations, just a star and emptiness. That's creepy. I had to show you that. The other thing I wanted to show you is over here. That's the Hyades. Remember them, that little V shape back home? And I told you they lost the bright star? They got one back. But it's not the same star. That's an accident. That's Merak. It just happened to drop into position and is as bright as our brightest nighttime star, Sirius. So chance encounters out there in the sky sometimes are one of the fun things you have to remember to look out the left side of the bus to see. Now, we're going to actually punch out the back of the Dipper here. We've gone about 80 light years. We're on the 80th floor. But the star at the end of the Dipper group is not one of them. It is so bright, 300 times brighter than our sun, that even from 120 light years, 40-odd light years beyond these guys, it looks as bright as they do, essentially. So this star, which they tell me I'm supposed to pronounce Dubhe, D-U-H-B-E, I believe, or D-U-B-H-E, it's Arabic, folks, and I'm just not fluent, okay? Alpha Ursa Majoris, if you prefer. This star is really a unique destination out here. It is what we call a red giant, and it's a monster. Flying into the system, you'd get to see quite a few things. Now, you folks may know that it's actually a real nice double star in your telescope. It's the red star with a fainter white star next to it. Pretty. Have a look at it. You can certainly find it. It's at the end of the Dipper Bowl. But this isn't that pair. This is that pair. This star out here, which is much fainter, we're just passing close to it on the way into the big boy, is a long way off, 9,200 astronomical units, I believe, from the main star. But as we get in close, we can see something you can't see from Earth. This is also a pair. And in fact, spectroscopy has also revealed this one is a pair. The whole system is a quadruple sun, okay? This is more exotic and exciting stuff. That big star being 300-odd times as bright as the sun, can you imagine what that would do to the Earth? Hold on, you don't have to imagine, let me show you. Welcome to Barstow. Now, this is a place where you put on your shorts and go down to the beach and watch waves of lead wash up and down. Very reasonable approximation of hell. This is a Kentucky Fried Planet. Its moon is sprouting wings here because it's turning into a comet. It's melting. All of the ice and so forth is long gone. Now it's working on melting the silicon, then working on the lead, and then working on the iron. Eventually, the inner planets will either fall into the star or be completely vaporized. Now, this will happen someday with our own sun, but this star is going through that phase right now. That doesn't mean, though, there couldn't be a nice place somewhere else, right? I mean, you've got to scoot off from the fire. There's got to be some distance from Dubhe here where things will be toasty and comfortable. Well, sure, but there's a problem. The kind of problem we don't have to deal with, called a companion star. See, if you back off from where you used to be comfy when this star, before it went through the expansion and turned into a red giant, the spot you scoot out to get comfy is 17 astronomical units out, about as far as Uranus is in our star system. Unfortunately, there's another sun at 23. So it would run you over like a Mack truck. The gravity would grab you and fling you out into the galaxy. You can't get comfortable here. Really weird. And you know what? This star's got a happy zone, 3 astronomical units out, because it's a little bit brighter than ours. So you scoot out there going into an orbit here, it could probably hold on to you with its gravity, probably. It's not that much lighter than the big boy. But you notice what's weird? Think about this. What happens when you're on this side of the sun? You're almost in the happy zone for the other star. Yeah, which means you getting sunshine from one direction and sunshine from the other direction. So you got two suns fighting to give you what's comfortable, and when you're out here, you're so much farther away, you're getting very much less radiation from the other star, so you are baked and frozen, baked and frozen. No way to win. The only comfortable spot in the whole system is out here. Any star going around, for example, this guy, would be in a situation like this. That's what it would look like if planets are in that weird situation. Now, in the background, something else worth looking at, this is the Kodak photo spot, right? We're on the 123rd floor, okay, on this trip, 123 light years from home. So we're looking down and back home, and this is the Big Dipper. All spread out and confusing and everything else. Let's get away from the other stars here, still in the vicinity of the Dubhe, and look at the stars so I can show you what's where. First of all, here's the Milky Way, and it may have changed already to looking a little different at this altitude. You notice the bright glow is on top now, it's not on the bottom. That's how you'll know when you cross the plane. That's my guess, that you would actually start seeing the glow shift to the other side as you start climbing out of the galaxy slightly. Now, what are all these guys? Well, these are the small and large Magellanic Cloud satellite galaxies of ours. For looking at the stars, you need help, a lot of help. You're a long way from Kansas here. There are a few familiar stars. Canopus, which is down in here, is bright, big giant star, still out there. Antares, yes, is still off towards the center of the galaxy. But Regulus is right next to the large Magellanic Cloud. That was one of the on-top stars. Well, the reason it's not an on-top star anymore is it's on the 83rd floor, and you're on the 123rd. It's down now, folks. And the Dipper stars, you can see, form a Dipper, minus, of course, Dubhe, which is the star you're at. This is the backside of the Big Dipper. Now, you all want to see home, don't you? Yeah. Okay. This is Sirius, the brightest star in Earth's sky. It's fourth magnitude from here. You want to see where we are? Point your telescopes. We are located right here. Magnitude 7.8. You need a telescope. The sun is as bright as the planet Neptune in a telescope here. Now, it just so happens, I'm not going to let you down, I brought a good telescope. I mean a good telescope. All right? And I can find that star, no problem. There's the sun, 7.8 magnitude, no problem. Got it in the crosshairs. You know, my telescope's actually a little bit better than that, though. I can enlarge this picture slightly. The 7th magnitude star, the sun's glare blowing out there, you know what that is? Let me enlarge it again, I'll give you an idea. From 120-odd light years, not too bad. Now, there's the little blue marble. You probably don't get a good sense of orientation from this. Hold on, let me enlarge it again. I can do that. I got a Barlow. Big Barlow. There's the Earth from Dubhe, and one thing you can see is you're not looking at the equator of the Earth. There's the top. There's the North Pole. Why? It's a northern star. It always sees the top of the Earth because it's over us. Now, there's Japan and China and, whoa, those aren't clouds. That's volcanic ash. Something happened. Something happened while we're gone. Something big. That's bad. That's covering the entire Indian Ocean. This is nasty. In fact, the volcanic eruption that pulled that off, that's bad enough to generate tsunami, earthquake waves, doubtless. It probably is going to alter the Earth's climate for a couple of years. Nasty sunsets for a number of years. This could be really bad. But you don't need to call home on your cell phones because you're watching the eruption of Krakatoa east of Java in 1883. It's 120 light years away. It's an old picture. Mark Twain is alive down there. Grover Cleveland is president of the United States. It took the light 120 years to get here. So we also back home, sure, it's 2004, go out, take a picture of Dubhe. It's 120 years old. Now, if you want to shoot pictures of your kids back home, don't bother. It's your great-great-grandparents, and they're alive, waving to you. Very creepy thing, and good for your sense of perspective here in the galaxy. Now, don't panic. we're turning around, we're coming back home, grab the air sickness bags. As I'm going to point her nose almost straight down and come barreling back through the Big Dipper group. And I'm going to nail the famous star in the Big Dipper. By that, I mean the middle one in the handle, I mean Mizar. Why is Mizar famous? It is the double star. It was the first double star photographed. It's famous in history as well. It was one of the first eye tests that was ever issued. It was used in the Babylonian infantry. If you wanted to get to be an archer, you had to identify which star was the one that was really two, right next to each other. That's the star. These guys are going back to the infantry. He's going to be an archer. And this guy's reading Cliff Notes, okay? So it is famous, and it was the first double star photographed, all kinds of other things. But it's not just a double star. As we cruise into orbit 88 light years away on the 88th floor, we see it in all of its beauty. Now, before we had blue stars, sure. But here you've got a double-double again. Basically, two stars like our own Sirius, next door neighbor, putting out about 30 times as much light as the sun, and basically two procyons going around each other, putting out about 15 or 16 times as much light as the sun. The entire system is so big that both pairs have room for planets to go around them. And adding to that, this is not the double star you see from Earth with your eyes. This is Alcor, the other star, which is only about 2 light years away and is magnitude -6. A very pretty collection of stars. Now, this is an amazing enough sight. The planets are probably barren because, of course, these are young stars you wouldn't expect to find on Earth. I mentioned that the best way to not appreciate a star cluster is to be in one. This is a good example from Mizar. There's Orion, again, kind of. And these stars here are all members of the Big Dipper group. You're inside it. They're scattered all over the sky. From here, as well as from back home, you would never notice that you were in the Big Dipper. Now, if you did find a planet that was getting started out here, and it was even starting to get water and all these things, promising, right? You're going to buy real estate? A lot of people do that. Very, very bad move, especially in California, okay? This is a planet you're going to end up upside down on your investment. And here's why. Those suns only live about 100 million years. Okay? So just about the time that the first life starts on a planet like this, the sun blows up, okay? And a lot of investors get upset with this kind of stuff. So don't get your hopes up on these planets. They don't have a chance because they don't have a boring sun like ours. Now, speaking of boring suns, let's zip on out of the Dipper cluster, come flying back down to about the 50th floor over here. Who would ever pay any attention to this star? Probably not. It's just a star like our sun. One of my favorites, though, you may have heard of it, 44 Boötis, if you're an experienced observer. It's a double star, a yellow next to a white, very pretty little pair in your telescope, good to look at, but boring, obviously, in the sky. I'm stopping here for a particular reason. Back behind us is the Dipper again, still looking pretty weird. Here's the white star, here's the yellow star. This yellow one is the one that's like our sun. They're far apart, room for planets around each one. If there was a planet in here, it offers the opportunity for one of the coolest sights you could possibly see. Now, if it had a desert planet, okay, if we get lucky and it looked like this, look at the sun real close. Something real wrong with the sun. The sun is double. It is actually going to change constantly because this is two suns that are rolling around each other, almost touching, and they roll around every 6 hours. So if you look at the sun, it will be round, and an hour and a half later, it would split into this, and then an hour and a half later, it would go back to being round and do it again, like a big pulsing heart up in the sky. Any culture that might exist here, and it could have planets, would end up regarding this as one of the fundamental units of time. And because they looked at the sun all the time, they would all be blind. I just think that's so interesting. And at the end of the day here, for the time to crack a corona, you get to see the Star Wars sunset, you know? Now, I look at these little stars, just a white star with a little yellow one next to it. A lot of stuff in astronomy, you have to know why you're looking at something. And for me, that just holds my attention, and I really wonder if there's a place like this you could see it from. And with the other star there, when that comes out at night, it'll be twice as bright as a full moon. Plenty of opportunities for romance here on this desert planet. All imaginary, but hey, that's what space is all about, it's using our imagination. One last stop, it's obligatory. We're coming past it. We can't help but stop on the 37th floor, 37 light years away, the star Arcturus. Arcturus, actually, Arctos was the Greek name for bear, and this constellation is the bear driver or the herdsman. He chases the bear across the sky, presumably because he's incredibly stupid and think he can pet bears or something. I don't know. You remember that guy, the guy who said he could pet bears? The grizzly guy? Yeah, you know what happened to him. Okay, that's his constellation. Wait till the bear turns around, and we'll see what happens. But Arcturus right there is another giant star. It's an orange giant at the end of its life. But Dubhe is 300 times brighter than our sun. This one's only 100 times brighter. Arcturus looks brighter because it's closer. So if you dropped into the system, though, still great opportunity to get fried. These planets are probably very, very toasty now. Notice Orion is starting to look maybe a little better. That's because we're getting closer to home. The main point to make here is that these worlds are all undergoing changes. This could have been a nice place that's now blasting hot. In the outer solar system, worlds that used to be icy could now be jacuzzi planets, with their ice melting into water, vapors escaping into space, all of this. Well, you know what, though? In the distant past, the coolest thing about this star system, Arcturus, would be revealed to you because of some of the changes. Now, you know that the planet's going to be colder, the moon's going to be colder, but if you can imagine 60 million years in the past, the sky would also look a little different. Because this star is one of the halo stars that orbits above and below our galaxy. This is like a farmer. He's out in the country most of the time. You only see him in the disk very briefly to come and pick up supplies. And then he's back off into the podunk nowhere. This guy's making a brief visit. 60 million years ago, Arcturus was a small, faint white star, or smaller and fainter, a couple times brighter than ours. The planets were a lot colder there. And the Milky Way center was not hidden by the dust clouds. It would shine as bright as the full moon out there. And the entire galaxy would be laid out as a magnificent spiral. Right now, we're passing Arcturus in our own lifetimes. So looking up and noticing that orange star is a chance to appreciate something unusual. But wait, there's more. One additional weird fact to freak you out about. The fact that Arcturus is diving through the plane of the galaxy, sure, it's a halo star, but we're starting to get ideas about where those halo stars come from. We've only recently begun to appreciate the galaxies are made by swallowing up smaller galaxies. Folks, the Magellanic Clouds are an example now. They're trapped in orbit around our galaxy. And galaxies that do this, smaller ones, after a period of time, the gravity of our own galaxy strings them out into streams of stars, widely separated. Eventually, all you're left with are these component stars. Arcturus might be part of another galaxy entirely. It is distinctly possible that it did not form with the Milky Way at all, but is a captured object, which would mean that if you could visit that star system and sample it, you might find something really different indeed, or some very surprised aliens from another galaxy. I don't know, but that's one more creepy thing to think about. That's our last destination, and we're preparing to drop back down home. I'm sure you're relieved to note. One other thing I should point out, things change in astronomy. We discover new things all the time. You'll notice this bright object right here. This is the only image where you will see Arcturus B. The reason the companion star is only shown here is that it was discovered just very recently, and I found it out only in the last months of preparing the talk, so I had to quickly do an image to do that. Our own sun is located down roughly in this part of the sky. If we come blazing on home, you'll expect to see the familiar, or not so familiar. You're dropping in from the top, guys, and things look a little different when you come in from a really weird side of your house. This is like coming home and driving through the roof, okay? That's Saturn. You're looking at the North Pole of Saturn. This is the way Ursa Major sees it. And the north part of the planet is in the shadow of the rings. You're looking at the unilluminated side of the rings. Now, as you fly around, maybe make a quick pit stop to visit the restroom on Mars. You get a chance to see the stars from Mars. Oh, sure, they all see the Big Dipper. It's bright in all of their skies. But one important difference, this pattern of the stars, Big Dipper, this is a star trail where you leave your shutter on your camera open, and the stars make streaks as they go around. But please notice that those stars connecting over to the North Star, Earth's North Star is not Mars' northern star. This constellation wouldn't have the cultural significance for those people. From Mars, it really is just another constellation. Their pole is way off here in Cepheus. So for them, it's another pattern of stars. The business of Ursa Major being so important in the celestial pole is a relationship to this planet. It is something special that our world has that no other world in our solar system can share. You can see, looking under the skirt of the Earth, there is the North Pole pointing towards the North Celestial Pole. Before we land, let's actually have one last look at the map here. Here's what you've seen. You've covered basically two constellations, going up 120 light years, coming down, and just getting the barest glimpse of what might be waiting for us out here. All these stars are waiting for you tonight to have a look at yourself. I've had to use my imagination, but I want you to remember, nobody really knows what's here waiting for us at this incredibly famous, brilliant, and important landmark in our little corner of the galaxy. Thank you very much. I appreciate your time and attention.